So, I'm in this video. I'm going to briefly show you our ESP code. Our ESP Python code is quite complicated. They have a lot of testing functions inside the code, so it makes the code like not very clear. So I'm going to guide you through the code to understand all the package. So basically, I'm not sure which version you have, but usually it is based on the ESP class. This Python file. We have all this package, and we import package with different names, or for example, we only import one function from this package, and only import ESP from input package. Those are some global parameters. And then so this is our okay. I'm not going to let's go to the main function first. So main function is very simple because, as I said, start from here until here, all these functions are testing functions. It has all the if you, for example, right now I'm only testing this one, and if you go to the here, if you go here, and this is what included in that package, and what is tested by the main program. For example, they have some definition here, like plot T2700 ESP and plot P100 DN1750. So in the main program, first one is connect to our database, because we already have a lot of test data, and if you go back to the beginning, here this is our these two functions is related to the database. All these test functions is comparing the calculation result to the test database. So you need to have this database function, and then you choose which testing functions you want to use. And so those are not very important, because those are just if we go to this one, okay, let's go through the go through it line by line. This is connect to database, and so this two-phase compare is a class, or is a calculation of this code. If you don't understand what is class, you need to check online to understand by yourself, to learn it by yourself. So so basically, this is connect to the database. This is our calculation, and this is we generate so this is connect to our database. This is generate some like a class, or some calculations using our program, our model. And this one is the data frame. This is you take the data from the database. You have, if you want to learn that, you check the SQL database, the language. But I'm going to only going to show you this is read from the database, and you select some data. For example, this is select all the data from this file, and right now you already have the data in these parameters, and this parameter is still empty because you create parameters, but you haven't do any calculation yet. But remember, this is, you already have the data in this data frame from our database. And then this one is you just select your data, and if you want to know how to use the data frame or data table, you can check by yourself. But this is something you find these parameters higher than 0. And this tool is create a plot. This is just create a plot. And now, if you remember, this is our data. We have the data from database, and we are creating a new data. We call it mapping data, and we are using this is kind of select data from this data table. When we have a we have a parameter called mapping, we are selecting those data point, and we are selecting the rotational speed, and then we also select the inlet pressure. So basically, those this is we generate new data table from our by selecting the specific data from our database, and then we create another database. So basically, those are all for experimental data, like how to select the data, how to make the average data, and then we plot. This is a scatter plot, and then we plot our data. So that's for our experimental data. Sorry, I here. Okay, let me see. Sorry, this is our experimental data, and if you remember, this is our we create another parameters to calculate for using our model and our programs. So this is a parameter to use our program, a class parameters, and we create a new data table by using our class program. And this one you can use. If you use a class, you can use the functions inside the class. So basically, right now this is a calculation. You use a calculation. This is the calculation, and you use all these parameters to calculate the ESP performance, and you have this model calculated data table. So this is experimental result. This is a calculation result, and finally you have this you plot. Okay, so this is you plot. Oh, sorry. So this is your experimental result. This is you from your experimental result you get this input parameters for your for our ESP model calculations, and so this is our input, and then by using our model we have the model calculation result. So this is experimental, this is model, and you plot experiment by a scatter plot, and then plot model by a curve plot, and so that is testing program. All these testing programs, they are similar. You just use a different different they have a different they select different data, and they select different, for example, rotational speed, but their idea is similar. So this is our testing function, and this four classes is our main class, like the model part. The first one, single phase model. This is the single phase calculation. So basically, this is friction factors, and this is how to calculate the emotion, like viscosity for emotion. And those are four different models developed by different person. Like this is probably developed by Jianjun Zhu in 2018. They have similar structures, but they have different correlations or empirical factors. So I'm not going to go through the details, but I'm going to go through one. For example, you have those input parameters. This is you just read the model, and those equations just follow the model. And finally, you have the input, and finally it gives you the this one is total boosting pressure or head of the pump in this input flow conditions, and those are like a liquid flow rate and the head loss for different terms, and all those different factors are similar. So those equations should be the same to our previous thesis or dissertations. And this is a single phase calculation. The performance curve is just by using these equations you calculate for a complete flow curve. In this curve we have like 100 points. It's going to sorry, we have 5,000 points, and we start from 50, and we first change the unit, and then we use the single phase model to calculate the head. We have the flow rate, and we can calculate the head or the boosting pressure, and then we create like a list or a matrix. We will when the head is less than 0, is negative, we will stop the calculation. This is within the. You probably can check the details by yourself, but this is basically the idea. For example, you run for 100 points and the head is less than 0, and there probably is some if there probably have some if statement in the calculations, but that's the idea. Like you have the flow rate, and then you calculate the head, and you have the curve. Once the curve is below 0, and we stop calculation. That is a single phase model. For the gas liquid model, it's kind of similar. You still have the two different. This is different correlations and different coefficients, and this is how to define flow pattern, and this is the whole idea of using the multi-phase flow pattern calculation. First, we use a single phase calculation. So basically, to initialize the parameters and check the emotion, and then this is a multi-phase calculation, and we have defined the this is multi-phase calculations, and this is select the different models, and if you remember, we have different correlations, and so you should have you should give the correlations as input, and then use all the equations in that function, and then calculate the error details, everything. And those are just follow the Dr. Jian Junzhu's thesis. You can just check the thesis for more details. So this is multi-gas liquid model, and this is single phase compare. So those two classes, something used in the testing. Those first two classes basic calculation, and those two classes to help you compare the result. So basically, for example, this one is you give the pump name, and you need to learn how to use a class online. But for example, this one is this is our input parameter. This represents class itself. This two is input parameters, and this is a class itself. So you have a pump name. When you have a pump name, it gives you the best match flow rate, and this one gives you the input parameters. If you go back to the beginning, this is input parameters. And connect to database. Just select some data from the database. And this is water, and this is just to calculate single phase water. you use first you create a class from this class, and then when you create a class, you can use all the function and subroutine within that class. So you have this one, and then you can make the calculation. This is just use you create a class named SGL single phase liquid, and then you use the performance curve in that class, and then you can plot the curve. Similarly, single phase viscose, you create a class named SGL, and you are using SGL's this function, and you can have this output. And you see this viscose fluid performance. You still similarly, this is an input, and you are still using this this class, and you are using these functions. And for this one, basically, you are creating a pump curve for a certain viscosity. So still similarly, you have a list of our flow rate, and this is a for loop to calculate the head versus for the flow rate. And you see this there is our if statement. So basically, if the horsepower is if the pressure is less than 0, we stop the calculation. And we are using this function to. This is only the one function to. This is one flow rate and one head, and the for loop is to have a complete curve. And that is the single phase compare class. And multi-phase compare class is this is still a self pump name connection. This is initialize of the class, and there are 5 different functions. So this is compare the surging test, mapping test, GVF test. This is probably like a test the different correlations. I think, yeah, you are this in this function we are testing different correlations, but they have similar logic. I will just use one example. For example, this one. First you have single phase as a initialization, and this is your selecting correlations. You see, we still have single phase. We are using our calculation class, and gas liquid we are using the second class. And we can use any functions within these two classes by using this two SGL and GL. And here we are using single phase to initialize the parameters, and we're using the this is a two class, and we are using like create a list. We are changing this to a list. And then we can calculate. We can use this list is single phase, and we are using this function. Gas liquid, we are using this function. So basically, we make the class more specific. This is a list of one function, and then you create a list of flow rate, and for example by using this this statement, you are, for example, if you have a list of flow rate, you put the list of flow rate into this function, this class, this function, and then it's going to give you a result of a boosting pressure list. Similarly, this is a gas liquid. This is a list of class functions, and you have the flow rate, and a list of flow rate. You put the flow rate into this class and this function, and it's going to return you a list of the pressure, and this is for different correlations. And so basically, right now you have a list of flow rate, and then a list of pressures for single phase flow, and you have a 3 list of pressure for different for gas liquid flow of different correlations. And finally, this is you create a data frame, and this is idea of the two-phase compare, and they are similar. They are using the similar method. So that's it.